This is the solution video for section 7.4, problem number 5. All right, so we're given a graph of some function called lowercase f. All right, let f be a function defined on the closed interval 0 to 7. The graph of f, consisting of 4 line segments, is shown above. Let g be the function given by g of x equals the integral from 2 to x of f of t dt. All right, so very important that we understand this is how g is defined. So in A, it says find g of 3. Okay, now initially this is just a function notation question. G of 3, well, g of x is the integral from 2 to x of f of t dt. So I'm interested in the integral from 2 to 3, right? 3 is put in for x of f of t dt. So take a look at the graph. I am interested in the area under the curve from 2 to 3. So I'm interested in this area, right? So you can think about it a couple different ways, but it's a trapezoid, right? So half of the width, which is 1, times base 1, which is 4, plus base 2, which is 2. So half of 6. So g of 3 is equal to 3. All right? So that's it. All right? Next, A says find g prime of 3. Well, in order to find g prime of 3, I need to think about, well, here's g of x. What is g prime of x? Now, this is the 7.4 question. This is the second fundamental theorem of calculus. How do I find the derivative of this function? I take x and put it in for t, so I get f of x, and then I multiply by the derivative of x, which is, well, 1. And so, very simply, this is a graph of f, but g prime is equal to f. So this is actually a graph of g prime of x as well, right? So this is a graph of g prime, right? So what is g prime of 3? Well, go to this function. What is this function, f of 3? F of 3 is 2. There is a point at 3, 2. So what is f of 3? It's 2. So what is g prime of 3? It's 2. Very simple, if you know the second fundamental theorem of calculus. All right, next, what is g double prime of 3? All right, g double prime of 3. Well, g double prime, well, if this is the graph of g prime, what would g double prime be? It would be the slope of this graph. So, in other words, we are saying what is the slope of this graph at x equals 3. So, take a look, the slope here, right? We have this line, and so you could do it just with basic slope formula like y2 minus y1 over x2 minus x1. So we have this point here at 4, 0. We have this point at 3, 2. We have this point at 2, 4, right? Whatever you want to do. So I'm going to use 2, 4, and 4, 0. So I'm going to take y2, which is 0, minus y1, which is 4, over x2, which is 4, minus x1, which is 2, right? And so 0 minus 4 is negative 4, over 4 minus 2 is 2. So this is negative 2. So g double prime of 3 is negative 2. All right? All right, that's part A. All right, part B. Find the average rate of change of g on the interval 0 to 3. All right, so average rate of change. So we are finding the slope of the secant, but remember, it's the slope of the secant on g. We're not actually looking at a graph of g, so we can't just do it so simply. But the slope of the secant would be found by taking g of 3 minus g of 0 over 3 minus 0, right? y2 minus y1 over x2 minus x1. All right, so now g of 3. Well, we actually already found that. G of 3 is 3 minus g of 0. All right, so now we're going to have to do a little work on the side. What is g of 0? That would be the integral from 2 to 0 of f of t dt, right? All right, so now what is g of 0? Well, g of 0 would be the opposite of the integral from 0 to 2, right? I can flip those limits. So what is the integral from 0 to 2? Well, let's go back up to the picture. Integral from 0 to 2 is this area of the triangle, right? So what is the area of that triangle? Well, 1/2 the base, which is 2, times the height, which is 4. So half of 2 times 4, right? 2 times 4 is 8. Half of that is 4. So g of 0 is negative, don't forget about that, 4. All right, so negative 4 is g of 0. So I get 3 minus negative 4 divided by 3 minus 0 is 3. So 3 plus 4, 7 thirds is the average rate of change of g on the interval 0 to 3.